At 07:42 a.m., on a wind-cut morning over Wright Field, Ohio, the captured German jet engine screamed to life. The hangar trembled as heat shimmered through the open bay doors. Engineers shielded their faces, the metallic howl rising beyond the decibel charts. Major Robert Lundy leaned forward, clipboard trembling, his pencil tip snapping. "Throttle at 60%, came the shout from the test stand. The Me-262's Jumo 004 engine, a prize dragged from the ruins of Augsburg, belched blue-white flame. Temperature climbed. The smell of scorched nickel and grease filled the air. A red line blinked on the thermocouple. Then another. 10 hours, Lundy thought. That's all these blades will live. What Germany had called the future of flight was now burning itself alive before their eyes. And for America's engineers, that was the beginning, not the end. May 1945 arrived with victory and questions in equal measure. Germany's surrender left more than prisoners behind. It left wreckage that whispered secrets. Wright Field's cargo bays filled with captured dreams. V-2 rocket components, armoured engine blocks, radar tubes, still warm from the factories of Peenemünde and Augsburg. In Hangar C, under armed guard and Klieg lights, sat the Messerschmitt Me 262, the first operational jet fighter in history. Its twin Jumo 04 engines were relics of desperation and brilliance welded together under Allied bombing raids. Major Robert Lundy had watched them unloaded from C-47 cargo planes 3 weeks prior. Burnt paint peeled from the cowlings, shot holes were patched with field solder. The engines smelled of burnt oil and cordite residue. "We're not here to admire it," he told his team of 15 engineers and mechanics. "We're here to make it tell the truth." The starboard engine was crated to test stand 7 using a chain hoist and wooden braces. Stamped steel construction, axial flow compressor design, crude compared to American standards, yet disturbingly alien. A memo from London's Technical Intelligence Unit described it as, quote, "technically revolutionary, yet fatally fragile." The classification stamp read, "most secret, eyes only." As the test crews prepared the wiring harnesses and fuel lines, they noticed something odd. The turbine blades gleamed dull grey under the work lights, not the bright steel they expected. Dr. James Warren, metallurgist from Purdue University, tapped one with a wrench. The sound was wrong, almost hollow. "These aren't high-temperature alloy," he said quietly. Lundy frowned. Yet they flew combat sorties for 2 years. Warren scraped a blade edge with his thumbnail. A faint powder came away. "On borrowed time," he replied. The room fell silent except for the hum of electrical generators. Each morning began with checklist rituals performed in near silence. Oil pressure verified. Fuel feed lines purged of air. Ignition timing calibrated to German specifications translated from captured manuals. The engineers wore leather aprons against flashback fires that had scarred Test Stand 3 the previous month. Every motion was deliberate, every bolt turned with something between reverence and caution. Private First Class Eugene Curtis handled the acetylene lines for preheating, his hands blackened with carbon soot. "They built this under bombing raids," he muttered, examining mismatched bolts and improvised clamps. "Half the hardware doesn't even match thread pitch." Dr. Warren joined the pre-test inspection on the second Tuesday of May. He carried a hardness tester and magnifying loupe. Tapping each turbine blade in sequence, he recorded Rockwell values in a leather notebook. The measurements were disturbingly consistent, far softer than American nickel-chromium alloys. "Cermet composite, chromium poor," he announced to the assembled crew. "These won't last a day under sustained heat stress." Lundy studied the worn blade roots through Warren's loop, microscopic cracks already visible. Yet they flew thousands of sorties across Germany and France. On 10-hour lifespans, Warren said flatly. Maybe less. They ran preliminary tests throughout the week, calibrating the RPM gauges against known standards. Above 8,700 rotations per minute, the exhaust gas temperature spiked like a fever breaking. The compressor whine took on a harmonic quality that made the concrete floor vibrate. One of the junior engineers joked nervously, "Sounds like it's begging for mercy." No one laughed. The joke hung in the oil-scented air like smoke. Outside, spring rain drummed on the hangar roof. Inside, men prepared to interrogate a machine that had nearly changed the course of history. By the third week of May, the team spoke to the Jumo 04 like a temperamental living creature, the compressor's rising whine before ignition, the starter motor's wet cough, the rattle of bearings spinning up to speed. Each sound meant something, a vocabulary written in vibration and heat. The Me 2632's technical manual, translated by German-speaking whack officers, read like a battlefield confession. Maximum thrust attainable for 10 minutes continuous operation only. Prolonged use risks, catastrophic, turbine degradation, and potential compressor stall. The typewritten English bore coffee stains and margin notes in 3 different hands. Wright Field's master logbook recorded 4 prior test fires of captured Jumo engines since March. All entries ended with identical notation. Blade failure. Thermal deformation at root attachment point. Test stand 5 still bore scorch marks from an engine that had disintegrated at 9,200 RPM. Still, Lundy pushed for another full-power test. He believed the answer lay not in the failure mode, but in the fact of survival. How had German engineers made jet flight operationally possible amid wartime scarcity? What shortcuts had worked well enough to matter? That afternoon, while others broke for lunch in the mess hall, Lundy remained by the test stand. He ran his fingers over a cracked blade, removed from the previous test. The metal felt different from American steel, lighter, grainier, almost porous. He could feel the desperation baked into its atomic structure, a component built from scarcity and mathematics, a gamble on thermal limits, yet strong enough to change the calculus of aerial warfare. Private Curtis returned with coffee in a dented canteen cup. "Major, you think we can make it last?" Lundy set the blade down carefully. "I think they showed us it's possible. Now we make it sustainable." Tomorrow they would push the rebuilt engine to 70% throttle. The turbine blades would either hold or teach them why they couldn't. June 2nd, 1945 arrived with clear skies, and a test schedule approved by Wright Field's commanding officer. Fuel lines primed with JP1 kerosene, instruments locked and verified. The hangar bay sealed against unauthorized personnel. 16 men took positions at their stations, some at control panels, others behind blast shields with clipboards ready. "Clear the test bay." Lundy's voice cut through the mechanical prep noise. The starter motor engaged with a grinding whine, then caught. The Jumo 04 engine roared awake, the sound like tearing sheet metal amplified through a canyon. Blue-white flames licked across the steel deflector plates. Temperature needles climbed, 650 degrees Celsius, 720 degrees. "She's running hot," Warren shouted from the instrumentation panel, but Lundy needed data points. "Hold current throttle." At 8,900 RPM, the first tremor registered on the vibration sensors. The compressor surged, a momentary reversal of airflow that belched black smoke from the intake. Everyone ducked instinctively. The engine's scream became piercing, metallic, almost biological. Then silence, sudden and complete. A turbine blade had melted through its root attachment, ricocheted across the concrete bay at supersonic velocity, and embedded itself in the far wall. The impact crater was still smoking. No one spoke for 5 seconds. The smell of vaporized steel filled the space. Lundy stepped forward through the heat shimmer, eyes stinging. On his clipboard he wrote in steady block letters, "Failure due to thermal creep. Alloy instability at 870 degree sustained load." And beneath that, underlined twice, "Redesign impossible under German wartime metallurgy constraints." He turned to Warren, whose face was pale. That's what they were working with. That's the miracle. That it flew at all. Warren nodded slowly. They built a revolution knowing it would eat itself alive. Outside, a transport plane roared overhead, its reciprocating engines a reminder of the age they were leaving behind. The team dissected the destroyed engine across 3 work tables, piece by piece. Each fracture surface told a story written in crystal grain boundaries and oxidation patterns. Warren placed the broken turbine blade under a metallurgical microscope, adjusting the focus until the structure resolved into clarity. "See this?" He pointed to the projection screen showing magnified grain structure. "Ferritic steel matrix, trace chromium, no nickel content, 0 cobalt." He pulled a classified document from a wooden crate stenciled Junkerswerke Technical Archives, 1944. The paper was brittle, typed in German with handwritten annotations. An attached translation read, "Standard mnemonic heat-resistant compounds unavailable due to Allied blockade. Alternative chromium molybdenum steels adopted under Emergency Directive RLM 443. That single wartime decision had doomed every Jumo 004 ever manufactured. The report included a photograph, a young German engineer named Erich Schiebele, standing beside a prototype engine at Junkers Dessau facility in early 1943. He was smiling, unaware his creation would burn itself to ash every 10 operating hours. The photo's reverse side bore a stamp, "Deceased, February 1945, Allied bombing." Lundy stared at the image for a long time. "We're not just studying their machine," he said quietly. "We're inheriting their mistakes and their genius." Warren nodded. They knew the limitations, built it anyway. The team fell silent. Outside, thunder rolled across the Ohio flatlands, low and continuous. The afternoon light dimmed through the high hangar windows. Private Curtis was copying temperature curves onto graph paper when he paused. What if we'd been in their position, blockaded, bombed, running out of time? No one answered immediately. Lundy finally spoke. "We'd have done the same thing, built what was possible with what we had." He closed the German report carefully. "That's why we're here, to finish what scarcity interrupted." History, it seemed, was still speaking, through fractured metal and desperate mathematics, through the wreckage of dreams that had flown too hot and too briefly. The lesson was written in heat and failure. Now they had to write the next chapter in endurance. To understand the enemy's limits, American engineers needed numbers, precise, repeatable, documented numbers. Wright Field's dynamometer laboratory operated in 8-hour shifts throughout June. The same captured Jumo 004 engine, now rebuilt with salvaged German parts and American instrumentation, was mounted, rebalanced, and prepared for systematic testing. Thermocouples ran from 12 critical points. Strain gauges monitored blade root stress. Oscillographs traced pressure waves like mechanical heartbeats across moving paper. The resulting report, designated JTID 262C3 and stamped confidential, tracked thrust output versus cumulative endurance time. Each test run followed identical protocols: startup sequence, gradual throttle increase, sustained operation at specified RPM, controlled shutdown. Every run ended sooner than calculated predictions suggested it should. At precisely 10 hours and 17 minutes of cumulative runtime across multiple tests, the turbine blades warped beyond operational tolerance. The degradation wasn't catastrophic, just progressive, inevitable. 10 hours, Warren repeated, almost reverent. That's the operational lifespan of their miracle. Yet in that weakness lay profound insight. American experimental alloy, 718C, developed by International Nickel Company with enhanced nickel and cobalt content, showed endurance projections 3 times longer under equivalent thermal loads. The data curves diverged dramatically after hour 6. By midnight on June 14th, the laboratory lights still burned. Lundy traced performance numbers on the master chart with a draftsman's compass, calculating not victories past, but futures possible. The war in Europe had ended. The Pacific theatre continued. But jet propulsion wasn't just a weapon system anymore. It was the future of every contested sky, every commercial route, every altitude record yet to be broken. Private Curtis brought fresh coffee at low 200 hours. "Major, you should sleep." Lundy didn't look up from his calculations. "I'm solving a problem that killed men because they didn't have nickel. That's not something you sleep through." The turbine blade sample sat on his desk, like an artifact from a tomb. Grey metal that had screamed through the sky above Berlin and Dresden and the Rhine Valley, burning bright and dying young. Now it would teach its killers how to live forever. News of Wright Field's jet engine testing spread through military channels faster than classified protocols could contain it. By late June, the Navy wanted involvement. Across the airfield, a rival team from the Naval Air Development Center arrived with their own testing agenda and separate command authority. Petty rivalries brewed in the corridors and mess halls, Army Air Forces versus Navy, each branch staking territorial claims on jet propulsion's strategic future. At lunch in the officers' mess, a Navy lieutenant commander named Halsey needled the Army engineers. "You boys going to melt another German engine? We could use the scrap metal." Lundy smiled thinly, didn't rise to the bait. "Not if we learn to build them correctly." The pressure came from higher up too. Washington demanded conclusive reports before autumn appropriations hearings. Classified cables already circulated regarding Britain's Rolls-Royce Derwent engine and General Electric's I-40 turbojet development. America's jet program couldn't afford to lag behind wartime allies or potential future adversaries. But none of the competing designs could match the Jumo 04's strange elegance, its sheer economy of parts, its brutal simplicity. 8 major components where American designs required 12. Stamped steel where others machined titanium. Germany's industrial ruin had handed them an unexpected blueprint. Now America had to make it survive peacetime scrutiny and production scaling. That evening, Lundy wrote a letter to his wife Margaret in Dayton. The censors would read it first, so he kept details vague. "These engines, burn bright and die young. Maybe that's what genius looks like when it's built under pressure. We're trying to teach them patience." He sealed the envelope and left it in the outgoing mail basket. Outside his quarters, summer fireflies pulsed in the humid darkness. Somewhere across the field, another test engine was being prepped for tomorrow's run. The competition wasn't just between services anymore. It was between what had been and what needed to be, between wartime desperation and peacetime perfection. The jet age was coming whether they were ready or not. The only question was who would define it. By mid-July 1945, Wright Field's engineers began the critical work of synthesis. German aerodynamic geometry merged with American metallurgical advances, the hybrid approach used Jumo 004 compressor blade angles and flow paths, but recast every component in superior alloys. Chromium-poor German steels were replaced by Inconel X550, a nickel-chromium superalloy developed by International Nickel. Bearings were remanufactured with pure nickel content approaching 80%. Combustion chamber liners received ceramic thermal barrier coatings unavailable to Junkers engineers. The test stand thrummed with cautious optimism as the modified engine was mounted. 16 connection points, 400 pounds of American improvement married to German innovation. When the hybrid engine ignited on July 19th, its acoustic signature was different, smoother, less tortured. The characteristic Jumo howl remained, but the desperate edge had vanished. Temperature readings climbed steadily without the wild oscillations that had marked previous tests. Warren watched the thermograph needle trace across calibrated paper. His hand was steady, but his voice wavered. "She's holding, Bob. 11 hours cumulative. Still holding." The hangar erupted in cheers and scattered applause. Men who'd spent 3 months breathing kerosene fumes and metal dust allowed themselves a moment of triumph. Lundy didn't cheer. He stood motionless at the observation window, watching blue-white flame pour steady and clean from the exhaust nozzle. His reflection in the armored glass looked tired and older than his 41 years. He whispered, barely audible over the engine roar, "We're crossing the threshold." Outside in the humid Ohio darkness, a courier truck idled near the administration building. Inside its locked cargo bay lay sealed orders stamped priority, Project P-80 Shooting Star. Lockheed's first operational jet fighter needed engines that wouldn't burn themselves to death. Wright Field had just proven it was possible. The Jumo 004's legacy would live on, transformed. Not German anymore, not quite American either. Something new, a hybrid born from ruin and necessity, rebuilt with resources the original designers could only dream of. The future had a designation now, J-33 GE-11, and it was already overdue. August 1st, 1945 arrived with heat and ambition in equal measure. They pushed the hybrid engine harder than any previous test. Continuous operation at 9,500 RPM, sustained thrust approaching 2,000 pounds. The modified power plant roared steady, instruments held within tolerances. Exhaust gas temperature peaked and stabilized. Pressure readings were textbook perfect. Then, at 12 hours 40 minutes runtime, a faint rattle emerged. "Bearing vibration, Station 4, Warren shouted over the roar. A tremor crawled through the mounting frame. Something deep within the compressor casing began producing a harmonic tone, not metallic grinding, but a singing resonance that made the concrete floor hum. The engineers exchanged glances. This was new, unanticipated. Seconds later, a fire plume tore through the exhaust pipe seam. Orange flame licked across the blast deflector. The safety siren wailed. 3 short bursts, meaning imminent failure risk. Men dove behind protective crates and steel barriers. Private Curtis yanked the acetylene shutoff. Lundy slammed the emergency cutoff lever. The engine died in a violent hiss of venting steam and superheated air. When the smoke cleared enough to approach, Warren inspected the turbine section with a flashlight and pocket mirror. One blade had cracked longitudinally, not melted, not deformed, fractured cleanly through the center web. Fatigue failure, not thermal degradation. Progress, written in the language of metallurgy. They had transcended the German alloy limitations, but encountered a new enemy, harmonic vibration at extended runtime. The pursuit of perfection was consuming time, fuel, and sleep. Lundy studied the crack pattern under magnification. "We're this close," he said, holding thumb and forefinger an inch apart. "This close to engines that don't die young." Warren nodded slowly. "The Germans solved maximum thrust. We're solving endurance." Outside, twilight was falling. Another courier truck arrived with orders from Washington. "Accelerate testing schedule. Pacific theater deployment pending." The war with Japan wasn't over yet. Jet engines might still matter in combat. But Lundy knew the real war now, the war against physics and time, would continue long after the shooting stopped. 1 week later, a decoded German document arrived via diplomatic pouch from London. The British Intelligence Objectives Subcommittee had recovered it from a partially burned filing cabinet in Munich during July occupation operations. The memorandum was dated November 18, 1944, typed on Juncker's Motorenwerke letterhead. 2. Reichsluftfahrtministerium Technical Standards Division. Subject: Jumo 04B1 Operational Limitations. Turbine blade. Operational lifespan limited to 10 hours maximum continuous use. Immediate alloy redesign impossible given current material shortages. Advise implementation of rotational maintenance protocols. Dr. Anselm Franz, Chief Engineer, Junkers Jumo Division. Lundy read the translation aloud to the assembled team, his voice steady but quiet. He knew. They all knew it wouldn't last. Warren stared at the document like it was a voice from beyond the grave. They built the future knowing it was temporary. The realization settled over the room like gravity asserting itself. The Germans hadn't failed from ignorance or poor engineering. They'd made a calculated gamble, accepted fragility in exchange for speed and altitude. They'd chosen 10 hours of jet propulsion over infinite hours of piston-driven obsolescence. That was their strategic breakthrough, not the technology itself, but the willingness to field it incomplete. Lundy underlined Dr. Franz's name with a red pencil. Beside it, he wrote in the margin, "They accepted death to reach the sky first. Courage or desperation?" He stared at the yellowed paper for a long time, feeling the weight of parallel struggles across enemy lines. German engineers fighting material shortages and Allied bombing. American engineers now inheriting their incomplete revolution. Private Curtis broke the silence. "Where is this Dr. Franz now?" Warren checked the intelligence summary attached to the file. "Captured. British custody. Being questioned." Lundy closed the folder carefully. "Maybe someday we'll ask him if he knew what he started." He looked around the hangar at the partially disassembled engine, the charts, the exhausted men. But we already know the answer. Outside, night had fallen completely. Somewhere in the darkness, another engine awaited its test. Final validation test. The culmination of 3 months' work. The ultimate hybrid model. American superalloys married to German aerodynamic geometry. Every lesson learned, every failure analyzed, every modification documented. August 9th, 1945 began with scattered clouds and perfect testing weather. Fuel lines primed with fresh JP1 kerosene. Control crew at stations. Safety protocols verified twice. At 07:15 a.m., ignition sequence commenced. The roar shook the hangar's steel framework. Paint flakes drifted from the ceiling beams. Time began its crawl. Hour by hour, the turbine blades held steady. Temperature curves tracked along predicted models. Vibration remained within acceptable limits. By hour 10, the entire engineering team stood at the observation window, in complete silence. Every eye fixed on the red line marker. 10:02. Stable operation continuing. 10:10. Still steady, no anomalies detected. 10:14. A faint shimmer in the exhaust plume, momentary temperature spike. Then nothing catastrophic, just endurance. just survival. 10 hours and counting, Warren said softly. His eyes were wet. We did what the Reich couldn't. They'd surpassed the limit that had defined the Jumo 004's operational ceiling. Not through radical redesign, but through material science and patient metallurgy. The engine continued its steady roar. 11 hours, 12 hours. At 1337 cumulative runtime, Lundy ordered throttle reduction and controlled shutdown. The engine wound down gradually. Turbine, whine descending through octaves until only cooling metal ticked in the sudden quiet. Lundy leaned against the steel railing, physically and emotionally exhausted. His hands trembled slightly as he lit a cigarette. "Tell Washington it didn't melt," he said to the room. "Tell them it evolved." Warren approached with the final instrument readings. Every data point confirmed what they'd witnessed. Sustainable jet propulsion was no longer theoretical. Outside, a radio loudspeaker crackled to life. Reports of a massive bombing raid over Japan, a new kind of weapon. The world was changing faster than engines could evolve. But here in Hangar C at Wright Field, a quieter revolution had just succeeded. The jet age had crossed its first real threshold. The results moved through Washington's bureaucracy with remarkable speed. Within 3 weeks, the Wright Field technical report circulated among military planners, aircraft manufacturers, and congressional oversight committees. Classification level, confidential, technical data, dissemination restricted, document designation, engine, analysis, 2602E, captured Axis turbine systems. The report summarized 94 days of continuous labor, 16 major test fires, 7 partial failures, and 1 fundamental truth, delivered in bureaucratic precision. Turbine blade operational endurance previously limited by inadequate alloy composition. Remedy achieved through high nickel composite substitution. Sustained jet propulsion operationally viable. That single paragraph, buried on page 47, became the seed of America's jet era. By late August, Lockheed's P-80 Shooting Star was conducting flight trials, with engines incorporating Wright Field's metallurgical findings. Across the Pacific, engineers at North American Aviation applied identical data to nascent designs that would become the F-86 Sabre. The thunder of the next generation was already building. But for Lundy's crew, victory felt quieter than they'd imagined. They stood in Hangar C, surrounded by silence and oil stains, the Me-262's disassembled carcass, hanging like a mechanical ghost on the overhead gantry. Warren spoke first, his voice carrying in the empty space. "You ever think we'll see peacetime last longer than these engines did?" Lundy didn't answer immediately. He closed his leather notebook, its pages filled with 3 months of measurements and marginal notes. "I think," he said finally, "that's what we're building toward. Engines that outlive wars." Private Curtis secured the final equipment locker. "What happens to all this now, Major?" "Reports go to Pratt & Whitney, General Electric, Westinghouse," Lundy replied. "They'll build what we couldn't finish. Bigger, better, longer lasting." Outside, August sunlight slanted through the open hangar doors. The war had ended while they were testing thrust curves and measuring blade wear. Japan had surrendered 3 days prior. The jet age would arrive in peacetime after all, and it would carry the ghost of German desperation transformed into American endurance. The lesson, Lundy thought, was written in heat and failure, and finally in survival. Years later, when museums displayed the Messerschmitt Me 262 behind polished glass and velvet ropes, few visitors noticed the small placard beneath the starboard engine mounting. Junkers Jumo 04B1 axial flow turbojet, operational endurance, approximately 10 hours before mandatory turbine replacement. Major Robert Lundy had long since retired by then, his service record noting Wright Field contributions without elaboration. But his engineering notebooks, filled with equations, thermal curves, failure analysis sketches, and coffee stains, were archived at the Air Force Research Laboratory's Technical Library at Wright-Patterson. One line remained, circled in red pencil on page 63 of Volume 2. Failure is knowledge written in heat and time. Success is making that knowledge last. Standing before the museum relic decades later, a new generation of aerospace engineers saw not the ruins of an enemy empire, but the blueprint of modern flight itself. They studied the crude compressor blades, the stamped steel housings, the desperate elegance of scarcity-driven design. The Jumo 04 had burned too bright to endure. 10 hours was its destiny and its limitation. But through its ashes and failures, through patient metallurgy and borrowed German geometry, the sound of the modern sky was born. Dr. Anselm Franz, the Junkers engineer who'd signed that November 1944 memorandum, knowing his creation was fatally flawed, eventually came to America. He worked for Avco Lycoming, contributed to the T-53 turboshaft engine, lived to see jets cross the Atlantic in routine service. When interviewed in 1962, he said only, "We built what was possible. You built what was sustainable. That is how progress works." The Me-262 behind glass remained silent, its story reduced to placards and guided tours. But in the living engines, screaming overhead, commercial jets, military interceptors, spacecraft launches, the DNA of that desperate wartime gamble endured. The jet age began not in triumph, but in the quiet hum of exhausted men listening to captured metal teach them how to fly. What Germany accepted as temporary, America made permanent, and the sky was never the same again.